Hi, I am Andre. Nice to meet you. So, in this video, we are going to prove two theorems of a trapezoid. Trapezoid is a part of the topic quadrilateral in geometry. So, do you know what is the quadrilateral? This is the definition of a quadrilateral. Quadrilateral is a polygon that has four sides. Here we have a theorem, the first theorem that we should prove. The theorem is the diagonals of an isosceles trapezoid are congruent. Prove the theorem. Wait, before we prove the theorem, do you know what is an isosceles trapezoid? Definition of an isosceles trapezoid is if two legs of a trapezoid are congruent, the trapezoid is known as an isosceles trapezoid. So let's continue. Here is the solution for proving the theorem. Solution. In order to prove that diagonals of an isosceles trapezoid are congruent, consider the isosceles trapezoid as shown below. Given isosceles trapezoid ABCD with line segment AD congruent with line segment BC. Proof. Line segment AC congruent with line segment BD. Since the trapezoid ABCD is isosceles with line segment AD congruent with line segment BC, the base angles are congruent. Therefore, the angle ABC congruent with angle BCD. Then, line segment BC congruent with line segment DC by reflexive of congruency. By SRS, side angle side theorem, triangle ADC congruent with triangle BCD. SRS means that side AD, this one, AD, side AD with angle D and side BC, or side BC with angle C and side BC. Therefore, it's proven that line segment AC congruent with line segment BD by CPCTC. That is, corresponding parts of congruent triangle are congruent. Next, the second theorem. The median of a trapezoid is parallel to each one. Prove the theorem. Wait, do you know what is a trapezoid? The definition of a trapezoid is a quadrilateral with exactly two parallel sides. Here is the proving for the theorem. Solution. Consider the trapezoid ABCD with basis line segment AB, line segment CD, and EMF are midpoints of line segment AD, line segment AC, and line segment CD consecutive. You can see on the screen the trapezoid with its point. Given a trapezoid ABCD with the median line segment EF, prove A line segment EF parallel with line segment AB, line segment EF parallel with line segment CD. Line segment AB parallel with line segment CD by the definition of a trapezoid. I believe that we have now the definition of a trapezoid because I have explained it before. That is, a trapezoid is a quadrilateral with exactly two parallel sides, which is the two parallel sides that mean is the base side of the trapezoid. That is AB parallel with CD. AE over AD equal to AN over AC equal to 1/2 by the definition of midpoint. So the intended midpoint is the midpoint of a line segment. The definition of midpoint of a line segment is the point that separates the line segment into two congruent parts, which is, in this case, the midpoint E, this one, this one of the line segment AB. Why it becomes 1/2? Actually, AD is to E, to AE. So AE over AD is equal to AE over 2AE. Then we can simplify it so that it becomes 1/2. It is also the same with AM over AC. Then angle DAC congruent with angle AEAM by identity, which is, it means that angle A is congruent to angle A, this one. Identity is also known as the reflexive property of congruency. The definition of identity is the reason we cite when verifying that a line segment or an angle is congruent to itself. By SRS, SAS, side angle side theorem, triangle DAC congruent with triangle EAM. Side angle side means that side AE, this one, AE, with angle A, this angle, and side AM, this side. Or side AD, this side, with angle A, this, and with angle, with side AC, this one. Then next, angle AEM congruent with angle ADC, angle AME congruent with angle ACD by CASDC. CASDC means that corresponding angles of similar triangles are congruent. Line segment EM parallel with line segment DC by lemma. So lemma that we use in this case is, if a line segment divides its two sides of a triangle proportionally, then this line segment is parallel to the third side of the triangle. Then line segment EM parallel with line segment AB by implication of line segment AB parallel with line segment CD. So line segment EM, this one, equal to line segment EF. Yeah, you can see that they are coinciding. So because when two lines share two or more points, the line coincide, we say there are only one line, right? So that's why AEM is equal to EF. So now it's proven that line segment EF parallel with line segment AB, line segment EF parallel with line segment DC by transitive property of equality. Okay, we have finished proof the two theorems. Thank you for you that have followed me in this video, and see you